The whole idea of producing things in a biological system create challenges that are unlike other industries. In the area of producing live cells, making proteins inside of cells, growing cultures, there's a lot of variables that you have to manage through that process that you have to control.
Aldevron's products, they're not manufactured on a machine of any kind. We have to first manufacture them in a living cell. So we're constantly playing a game between yield and purity. We want to maximize the amount of target protein we recover and minimize the number of impurities that are carried along with it.
The risks are really threefold. It's the expense of doing the work, it's the speed at which you can do it, and it's the quality of which you can deliver it at. Ananth came to me a few years ago to say, hey, we want to apply these math models and this way of thinking around quick response manufacturing to the biological industry. I'm like, let's do this.
So this research, at the core of it, looks at the issue of scalability of engineered proteins. As engineers, we may not understand the science as thoroughly as the experts do, but by patiently and closely working with the scientists in the field, we as engineers are able to develop techniques that are not only able to reduce timelines, but also the costs related to the drug development process.
During this collaboration, I had weekly visits to Aldevron over the last 2-3 years, and I mainly observed their operations, shadowed their processes, and tried to understand the daily challenges they face in the lab. The tool that we have developed for Aldevron is using some stochastic optimization models, especially the theory of sequential decision-making under uncertainty.
If the combination of quantity of our target protein and impurities falls to the gray zone, we're in a much better space.
What the tool does is it takes the information from the scouting runs, abstracts it into the mathematical model, and uses that information to tell you how to scale the production directly into the production runs. And that allows Aldevron to potentially skip the validation runs, which could mean about a 30% reduction in lead times and 20 to 25% reduction in cost.
The process of manufacturing a biotherapeutic is very complex. The ability to better utilize our scouting data, eliminate the engineering runs, is a tremendous savings of time and materials. So we're reducing labor costs, reducing material costs, we're accelerating delivery of the final product to our clients.
When we're dealing with process control here, we're talking about an investment to produce a 50-liter culture. But our clients are producing cultures that are 5,000 liters. And so if we can build the model here and demonstrate the feasibility of how it works and the reproducibility of how it might be applied, our clients could also do that. If they can reduce healthcare costs, that could be then directly passed off to the patients.